some functions you can't just use the product, quotient, or other rules. You have to use the chain rule. The chain rule works like this. If f prime of x equals f prime of g of x multiplied by g prime x. So if you're given a function like cube root of some, I don't know, some random polynomial or some trig function that's like super hectic, like this. Wait, that's it. We can't use the product, the quotient rule, and that's it. We have to separate the function into multiple parts and then take the derivative of each part, I guess. So that's why we have this equation here. So let's do an example problem. So let's start out with f of x equals the square root of 3x plus 2. It's a fairly simple problem. So if we remember, f prime of x equals f prime of g of x times g prime x. So let's split this up into f of x and g of x. So the square root function can be f of x. So I guess f of x is equal to the square root of g of x. And then g of x is just going to be equal to 3x plus 2. And if we put these together, we will get this. So everything is legal so far. Now let's take the derivative of that. So f prime of x is equal to, if we have a square root, we can rewrite that as g of x to the negative 1/2 power, or sorry, to the just negative 1, or just to the 1/2 power. And then if we want to find the derivative of that, this is f prime. If we want to find f prime, we just move the exponent to the front. And then we have n minus 1 in the numerator, so 1/2 minus 1, or minus 2 over 2, is a negative 1/2. So f prime of x equals 1 over 2 square root g of x. Anything to 1/2 power is basically just, you're going to move to the denominator. So we're going to move, because we have 1/2 g to the x to the negative 1/2 power, we're going to move this part to the denominator with the 2. So we're going to get 1 over 2 to the gx to the 1/2 power. Like we set up here, g to x to the 1/2 power is just equal to this. So we're going to have 2 times the square root of gx, which is how we got this. Now let's take the derivative of g. Take the derivative of this. So g prime, we just use normal rules for this. N to the x, or x to the n power, the derivative of that equals, or the derivative of x to the n power is equal to n times x to the n minus 1. So we have 3 to the 1 power. So we're going to have just 3, and then the derivative of any constant is 0. So now we have f prime of x and g prime of x. Now in the g of x, we're going to plug this in here. So our final answer is going to be f prime of x, this f prime of x equals, we have 1 over 2 to the square root, and then g of x is just 3x plus 2. It's just this part, the x multiplied by 3, which just gives us 3 over 2 times the square root. For our next problem, let's take the derivative of the square root of x over x plus 3. So we're going to have to use the chain rule for this problem. And similar like we did last time, let's write f prime of x is equal to f prime g of x multiplied by g prime x. And then we're going to split up this equation into f of x and g of x. So f of x is going to equal just square root of g of x. And then g of x is going to equal x plus, or x over x plus 3. If we combine these, we can get the square root of x over x plus 3, which is matches. So our work checks out. Now let's take the derivative of f of x and g of x. So the derivative of f of x, like we did in the last problem, it's going to be 1/2 times g of x. It's negative 1/2 power, which just equals 1 over 2 to the square root g of x. Now let's take the derivative of g of x. And to do this, we're going to have to use the quotient rule. So if we remember, the quotient rule is f prime g times g prime f divided by g squared. And we have x over x plus 3, we'll call x f, and we'll call g, or we'll call x plus 3 g. So f prime, so I'll write f for this problem here. For the sake of this, we're going to have f prime equal, or we're going to have f equal x and g equal x plus 3. The derivative of x is just 1 times g is x plus 3. This is multiplied by g, the derivative of g, which is just 1 times x, or times f, which is just x. Sorry. Quotient was actually minus. Let's be a minus here now, multiply. It's f prime g minus g prime f all over g squared. In the denominator we have g squared, so if x plus 3 squared. We can simplify that. So we have x plus 3 minus x over x plus 3 squared. The x's cancel out, so we're just left with 3 over x plus 3 squared. So this is the derivative of g. This is the derivative of g prime. So now we can combine them. So we have f prime here, and then we have g prime. So the final answer can be y prime equals 1 over, this is f prime. Now what's g? G of x is just x over, this here is just x over x plus 3. And multiply it by g prime of x, which is we use the quotient rule, and we got this. So we're going to multiply by 3 over x plus 3 squared. That should be our final answer. This is the derivative of the square root of x over x plus 3. For our last problem, we're going to let f of t equal tangent of the square root of 2 plus t squared. So we're going to have to separate this function into 3 separate functions. So when we're going to, from the chain rule, we're going to go from the outside in. So first, let's take the derivative of tangent x, which is just secant x squared. So let's take the derivative of tangent. We'll call this, actually, I'll separate this into 3 equations. So we'll have f of x can equal tangent of x, or tangent of, let's call it h of x. H of x can equal the square root of g of x, and g of x can equal 2 plus t squared. Now, if we combine all of these, we will get this, we'll get this entire equation. So make sure, if you're going to write everything out, make sure if you add them all together, you get the right equation. So we've separated this into three functions. Now let's take the derivative of each part. So first, let's take the derivative of tangent of x. So derivative of tangent x is secant squared x. So we're going to have secant and then h of x squared. So we're just going to have the square root of g of x, which is 2 plus t squared. Remember, the derivative of tangent is secant squared, so we have to have a square here. Now let's take the derivative, multiply this by the derivative of the square root of g of x. So we're going to get 1/2 times g of x to the negative 1/2 power. Now we're going to take the derivative of g of x, which is our last step, which is just 2t. So we can simplify this to f prime of t equals, so secant x, so we have secant of 2 plus t squared to the second power multiplied by, if we simplify this, we'll get 2 over the square root of 2 plus t squared over 1 basically, and then we just have 2t in the numerator. The 2's can cancel out, so the final answer is secant of 2 plus t squared, all this squared, times t over the square root of 2 plus t squared. And again, if you're not sure how I got here from this to here, it's basically we've seen it in the last two problems, so go back and watch if you don't understand it yet. And yeah, this is the final answer. It's the derivative of the tangent of the square root of 2 plus t squared. Like and subscribe, and give me any video ideas.